where scientists from around the world work together to answer some of the biggest questions about the universe. Through expert talks, I also welcome Dr. Vipul Khairat sir from SPNIT Physics Department. Thank you so much, sir. Thank you for being here, and let us begin the exciting journey into the world of particle physics. I also would like to thank our in-charge principal Manisha ma'am for supporting us for such an event. I will invite her to say a few words for the event. Ma'am, please.
Hello. Hello. Good morning, all of you. આજના પ્રોગ્રામમાં ઉપસ્થિત અન્ય કોલેજમાંથી પધારેલ પ્રોફેસર અન્ય કોલેજમાંથી ઉપસ્થિત સ્ટુડન્ટ, મારા કોલેજમાંથી અહીંયા ઉપસ્થિત હેડ ઓફ ડિપાર્ટમેન્ટ પંડ્યા સર, અન્ય ફેકલ્ટી ફિઝિક્સ ડિપાર્ટમેન્ટના કીર્તિબેન, અનુરાગભાઈ, સર્વ સ્ટુડન્ટ. આજે આ કાર્યક્રમમાં આપ સૌનું હાર્દિક સ્વાગત કરું છું અને એક ગૌરવની લાગણી પણ છે કે શોર્ટ ટાઈમમાં આપણે આ પ્રોગ્રામને અહીંયા બધા આપણે અહીંયા ઉપસ્થિત થઈ ગયા છે. અને કદાચ મને પોતાને પણ એવું હતું કે સ્ટુડન્ટ 10-15 સ્ટુડન્ટ આમાં આપણે મેડમ સાથે પણ વાત થઈ હતી, પણ સારો એવો રિસ્પોન્સ મળ્યો છે. આપણી વચ્ચે અન્ય કોલેજમાંથી પધારેલ પ્રાધ્યાપક અને મહેમાનને આજે હું પોતાના વ્યસ્ત સમયમાંથી ઉપસ્થિત થયા છે, સમય કાઢ્યો છે, તો એમને પણ અહીંયા આવકારું છું. એક વાત કહીશ કે પોતે હું બાયોલોજીની છું પ્રોફેસર, મારો ફિઝિક્સ ભણેલી, પણ એક એક્ઝેક્ટ ટાઈમ મને ટફ લાગતું હતું. પણ આજે મને એવું લાગે છે કે આવા જો પ્રોગ્રામ મને એ વખતે મળ્યા હોત ને તો આજે ફિઝિક્સ એ ટફ નહીં હોતે. કારણ આપણે આજે જે તમે લોકો આ અભ્યાસ કરવાના છો ને એ લાઈવ સેશન છે તમારા માટે, બરાબર. પાર્ટિકલ ફિઝિક્સ પરની વાત કરવાના છે તમને. થોડી વાત કરું તો ભૌતિક વિજ્ઞાનની જે એક મૂળભૂત અને આધારભૂત આપણે શાખા ગણીએ અને સૌથી અગત્યની એક બ્રાન્ચ તરીકે આપણે લઈએ છીએ, એ પછી પરમાણુની રચના સુધીની હોય, કોઈ પણ રહસ્ય સમજવાના હોય તો એના માટે ફિઝિક્સ સૌથી અગત્યનું છે. દરેક બાબતની અંદર ફિઝિક્સ જરૂરી છે. ખાસ કરીને આજના આ યુગમાં ભૌતિક વિજ્ઞાન એટલે કે ફિઝિક્સનું મહત્વ વધ્યું છે. એ પછી અવકાશ હોય, ક્વોન્ટમ હોય, નવી ઉર્જા એટલે કે રિસોર્સિસની વાત હોય કે પછી પાર્ટિકલ ફિઝિક્સની વાત હોય, દરેકની અંદર આપણને ફિઝિક્સનું ડિમાન્ડ વધી છે. અને તમે જેટલા એમાં ઇન્વોલ્વ થશો, જેટલા ઇન્ટરેસ્ટ લઈને કામ કરશો, જેટલા આવા સેમિનાર એટેન્ડ કરશો, અને એક વાત નક્કી કરી લો કે આપણી વચ્ચે જે પ્રોફેસરો છે ને એમની જોડે કંઈક ના કંઈક છે, એમની જોડેથી આપણે ક્યાંથી કેટલું આપણે નોલેજ લેવું એ તમારે નક્કી કરવાનું છે. મેક્સિમમ ઉપયોગ કરો તો તમને ફિઝિક્સ હોય કે કેમિસ્ટ્રી હોય કે મેથ્સ હોય કે બાયોલોજી, તમે એમાં ઇન્ટરેસ્ટ તમને ઓલવેઝ થવાનો છે. ખાસ કરીને આ સમય હું એક તમને કહીશ કે આજના કાર્યક્રમમાં માત્ર સાંભળવાનું નથી, શીખવાનું, ચર્ચા કરવાનું, સૌથી અગત્યનું ક્વેશ્ચન આન્સર. જેટલા તમારા ક્વેશ્ચન વધારે એટલું હું એમ માનીશ કે આ પ્રોગ્રામ સક્સેસ છે. અને ક્વેશ્ચન ત્યારે જ ઉત્પન્ન થાય છે કે તમે કંઈક સમજ્યા છો, નહીં તો કોઈને ક્વેશ્ચન જ નહીં આવે. કોઈ પણ પ્રોગ્રામ પત્યા પછી જ્યારે ક્વેશ્ચન આન્સરનું સેશન આવે ને અને નોટ એ સિંગલ ક્વેશ્ચન, તો સમજી લેવાનું કાં તો બધી સમજ પડી છે, પણ એવું હું નથી માનતી, પણ સમજ જ નથી પડી એટલે આપણે ક્વેશ્ચન નથી કરી શકતા. એટલે આજનું સેશન મારું હું એવું માનું કે તમે અહીંથી આ તમારા જેટલા કલાક હવર્સ છે એમાં તમે કંઈક ને કંઈક શીખીને જાઓ અને તમે જેથી કરીને એ લોકો પણ આવા સેમિનારમાં જેમાં ઇન્ટરેસ્ટ ધરાવે અને એ લોકો એમાં પાર્ટિસિપેટ. ઓકે, તો છેલ્લે હું તમને એટલી વાત કરવા માંગીશ કે ઓલ સારી વેલકમ ટુ ઓલ ઓફ યુ. આ પ્રોગ્રામમાં તમે સંશોધન એટલે કે હવે આઈ થિંક
એલિજિબલ સ્ટુડન્ટ છો તો તમે નેક્સ્ટ યર રિસર્ચમાં એમાં જવાના છો તમને એ હેલ્પફુલ થશે જેવું એક આશા
Hello. Thank you so much, ma'am. Okay.
છોકરાઓ તો મોસ્ટલી વિવેક પટેલ ઓળખે છે કારણ કે ઘણા બધા કિસ્સાઓ અમે ડિસ્કસ કરતા હોઈએ છીએ આપણામાંથી જ એક પર્સન જો हमारे अपनी पहले बोलना चाहिए तो इसमें बात कर रहे हैं
Okay, students from Navyug Science College, mostly they all know Vivek Patel. He is just from us and वो हमारे जैसे एक नॉर्मल ऑर्डिनरी स्टूडेंट से लेके यहाँ तक की जर्नी तय की है तो that is amazing introduction. I would like to invite Anurag to give his brief introduction. Anurag sir, please.
Thank you, ma'am. So I would like to invite our first speaker for the day, Dr. Vivek Patel. Here is his introduction. Vivek Patel, sir, he has done his postdoc at National Institute of Nuclear Physics, INFN Bari, Italy. He did his PhD in Detector instrumentation from Bergisch Universität Wuppertal, Germany. He has worked at Rich Detector for the CBM Hades experiment of GSI. Currently, he is working on characterization of silicon sensors for the Alice ITS3 upgrade for CERN and EPIC EIC SVT for the Brookhaven Labs US. His work includes characterization of sensors and readout electronics. I welcome you, sir. Hello. Okay, let's do this sci-fi thing. So I would start this kind of lecture, and you don't have to worry. Okay, it will get hard later, but for now this one is easy. Okay, we don't want you to sleep from the start. Or as I said, or from the introduction, we will discuss how these large-scale facility works. Now, the entire motivation for me to push for this workshop was that these are really, really big facilities. You just see like what glamorized in TV or National Geography or Discovery or maybe from your colleagues. And there is a lot of opportunities there for everybody, but the assumption or presumption is made that only cream crowd can go there, which is kind of true, but it's not. There is a gap where you also can be, go there. As I said, I'm just like normal person like you. मेरा कोई ऐसा डिग्री नहीं है IIT, NIT ऐसा कुछ नहीं है. I did my master's BSc from PT Science. Then I was in SGU. I failed twice, not once, twice. Okay, मेरे BSc और MSc के बीच में 5 साल का गैप है. Then I went to MS and got 60% first class. Okay, then I was in NIT. I was teaching that. आपके next speaker जो है उसका TA था मैं तब. And then I moved to. Still I was here, and then I was assistant professor in ML Parmar College for some time. From there, I moved to Germany for PhD, so on and so forth. So, long story short, if you have enough motivation, you can be in these things. And I want you to show the part of the world now what I see. Okay, so chill. It's not so complicated thing right now. We are just taking a roller coaster here. Yeah. So for the start, what is a large-scale experimental facility? Okay. As you can see, this is where I did my PhD. I was in University of Wuppertal, but our project is somewhere here. Okay. कहाँ गया हमारा ये है SS18 and maybe somewhere here or here I don't know. पर ये हमारा छोटा सा एक केव था जहाँ पे हमारा सेटअप था. Okay, that is where the hardest experiment is there. I will show pictures of that at some point. But if you can see, यहाँ तो ये तो schematic है. Okay, but this is the actual satellite picture. This thing is around 800 to 900 meters in circumference. So it's a really big facility. And it's Germany's largest heavy ion collision thing. So अब ऐसा हो गया है कि at least in West that these things are not just like normal labs. They are like corporate companies. Okay, इसके directors होंगे, नीचे बड़ा बड़ा facility है, millions of euros का इनका project होता है. Okay, large scale international collaborations होते हैं, collaborating partners होते हैं. It's like a corporate company, like from Google, Facebook ऐसा company की तरह काम करते हैं. So this is where you need to know how things work. And as you can see, this is where I did my PhD. So ये वाला picture है. But then you see again, this is RIC, which is Relativistic Heavy Ion Collider, USA. Fermi Lab, who started this trend. Now this accelerator is not there. It is world's first accelerator who could accelerate the particles at EV range. Okay, this was my motivation to study particle physics actually. When I was in PT Science, I heard about this thing 2002 and I decided that one day I will work for Formula Tevatron. एक बार तो वहाँ कदम रख के कुछ तो करूँगा. By the time I reached there, ये dismantle हो गया because of my career setbacks. Fortunately, they decided कि उनके पास बहुत पैसा है, so they will make another one in this place. CERN. We all know this. Okay. So they got money. They made even bigger one, 27 kilometers here. Okay. And now that I see, okay, back then when I was at your age, I was like really struggling and thinking कि अरे क्या है ये, मतलब कुछ जा नहीं रहा है life. And I had lot of setbacks. She is my very personal friend, like, तो उसको तो पता है क्या चल रहा था. And now when I see, it's kind of like world का सबसे बड़ा facility है. So this is the largest. This is almost similar scale. Accelerator इतना बड़ा नहीं है, but energy scale is almost similar. What they do, okay? So this accelerates protons, but they accelerate ions. So you can see if you have a lead-lead collision or calcium-calcium, then number of atoms in per collision is almost in the same order as this thing. So एक ऐसा है मतलब कि तुम यहाँ Ferrari चला रहे हो, यहाँ पर तुम ट्रक चला रहे हो. It's like that. That's the analogy I would say. So energy scale is almost same. And now I'm affiliated to all top three accelerator facilities. I did my PhD from the third largest accelerator facility in the world. And now I'm currently affiliated to RIC because there are the current project here, EIC, EPIC, SVT जो आपने सुना, that is here. And the second one or the same one is in Alice, which is in CERN. So now I am you can say at the peak of my career in that sense. And I want to share that part. I want you also to have that part. और आपका इजी हो जाए क्योंकि मुझे 20 साल हो गया उसमें क्योंकि हमको कोई गाइड नहीं करता था तब कुछ पता नहीं कैसे जाना है पता ही नहीं है मतलब कौन ले जाता है कैसे अप्लाई करना है इट टुक अस 20 years otherwise it's like अगर सब बराबर प्लान करो it's like normal BSc MSc PhD and you are there in 5 years so anyways we all learn from others examples or we should actually. Yeah. So what happened? Yeah. Anyways, so this is now CERN, which will become world's largest facility soon, even bigger. जो LHC आपने 27 kilometers का देखा ना वो ये रहा. And they just got $18 billion to make this one. Just few months back. So now they are going to make a 100-kilometer one. This thing, what you see here is Geneva Lake. Okay. So काइंड ऑफ एक सी जैसा है, उसको भी वो लोग अभी टनल बना के उसके नीचे से निकालने वाले हैं इसको. And this is France, this is Switzerland. So these are this kind of facilities. Okay, there will be a lot of opportunities because once this goes, into let's say production run or something, there will be a lot of opportunities. So for you, that if you are interested in particle physics, you have a nice future there. Next, please show that. Yeah. And if you think India में ऐसा कोई facility नहीं है, then we also have one this RRCAT Indore, which is again a very large scale facility. It is more related to material science if you are interested in, because this is an electron accelerator. It's one of its kind, and then you can have a lot of free electron laser ये सारा facilities है. And they also run a school, accelerator school चलाते हैं. Or it is for students actually. So there is like a month or so of your vacation time you can spend there. They will teach you everything about this. क्योंकि ये हर college में तो हम बना नहीं सकते. So they run this school. You can apply for that and so on and so forth. Then coming back to CERN, as I said, it's largest facility. So करते क्या है ये लोग? इनके 4 बड़े experiment है. Atlas, CMS, ELIS, LHCb. And then there are other experiments also, but we will focus on these 4 because that makes a lot of use. Atlas CMS general purpose detectors है, wide range of physics including Higgs boson. Higgs boson basically was detected in Atlas. So हर T-shirt पे शायद वही है, probably, I don't know, maybe, or CMS. But that thing is case, maybe he will indulge a little bit into it. But that is the goal of Atlas and CMS. ELIS is specialized to study quark-gluon plasma. That is all together. ये आपका अगर CERN का जो live telecast होगा ना जब 3:30 को, so I will say spokesperson of ELIS जो है, he himself is better person to explain everything. So I will leave up to him. But more, if I just want to give you a glimpse, then this actually kind of does more like cosmology or astroparticle physics कह सकते हो, because this studies how universe was formed after Big Bang. उस question को कि पहला matter particle कैसे बना, how photons came into existence, and those things, those questions are answered by ELIS. LHCb for beauty quark की properties and anti-accelerate करते हैं. And recently, very recently, they have an experiment where they did was एंटी हाइड्रोजन बनाया था. और आप लोग जो 12th स्टैंडर्ड या फर्स्ट ईयर में करते हैं ना बोर्ड एक्सपेरिमेंट, तो स्पेक्ट्रल लाइन वाला, वो सेम एक्सपेरिमेंट एंटी मैटर से किया था, एंटी हाइड्रोजन से. ओके, सो लॉट ऑफ इंटरेस्टिंग थिंग्स. एंड देन यू हैव अदर also small and big, they are also into medical things and all, because इतना बड़ा facility है, so you can do a lot of things out of it. So these 4 accelerators and now detectors. Okay, जो LHC experiment है वो. Each experiment is a collaboration of thousands of scientists around the world. As you can see here, this is, and you can see the enormous sizes of these things. So this is LHCb experiment. Okay, this is of manpower. Okay, to show these things, to make this thing. Lot of energy, resources, manpower, and money is required, and that is how you make these things. So that is just a glimpse for that. So now I will just come back to again. This is also like क्योंकि मेरा PhD इसमें था and which is related to ELIS PhD, ELIS experiment. Sorry, that is why I will focus on that. So one of the aspects which we study is why, as I said, why and how universe was formed. So Big Bang से ये जो current situation है हमारा, where you have this very stable things, star structures and expanding universe and all the things which you study in astronomy, astrophysics, more interested in what a lot of things happen, and it's very interesting. So you have what you call nuclear phase diagram and all that thing. और तपन सर का जब lecture होगा उसमें वो समझाएंगे भी कि क्या होता है. I don't know if I have kept the slide, but next, या नहीं है. So anyways. The point is that we want to know how these protons and electrons and everything started from just pure energy. Okay, so that is what they study. We in ELIS experiment we do these kind of collisions and then we try to recreate these situations You must have heard also when this Higgs boson का जब the CERN का जब collider चालू किया था, तो in media there was like lot of news and sensationalized that we are creating black holes and then the Earth will get destroyed in that black holes and all that thing. So actually we create those who are from really first year or nearby that वहां से है, तो आपको शायद अभी तक बहुत कुछ इसमें से नहीं पता होगा. नॉर्मल पार्टिकल फिजिक्स जो आपको न्यूक्लियर फिजिक्स में आता है, तो उसमें आपको प्रोटॉन, न्यूट्रॉन, इलेक्ट्रॉन होगा, कुछ क्वार्क्स के नाम पता होंगे. दिस इज ऑल द पार्टिकल्स व्हिच वी हैव क्रिएटेड एंड दीज लैंडमार्क्स आर नथिंग बट जस्ट व्हाट यू कॉल नोबेल प्राइज. तो इतने नोबेल प्राइज मिले हैं, बट इसके बीच में बहुत सारा है. दिस इज कॉल्ड पार्टिकल जू नाउअडेज. ओके, and next, so when you arrange them just like periodic table, you create what you call standard model of physics. Okay, I will just go in little bit detail, and I have tried to create an infographic. Otherwise it's particles and then you have force carrier. Force carriers, जो हमारे चार fundamental force है, how do they communicate? So if you have gravity है, तो the presumed particle is graviton, or if you have electromagnetic, then the presumed particle is, or not presumed, but we know that it's photon. So these are force carriers. And then you have matter. Matter are of again two types, leptons and quarks. Leptons don't have any substructure. For example, electrons, neutrinos, they are fundamental particles. While you have quarks, they are again fundamental particles, but in two different compositions, they make the secondary particles or higher order particles called baryons and mesons. So baryons, the famous baryon is proton. We all are made up of that, the entire universe. And then you have mesons, where the most famous ones are pions. Okay, you will see them everywhere. Common mesons. I don't know if this hyperlink works, but if suppose you want more details, so मैंने एक बहुत ही intuitive blog लिखा है. You can read that, so you will get to know everything and some of the historically क्या चीजें हुई थी जब ये सब discover होता था. So this is the blog. And there are a lot of things there which you can क्या बोलते हैं know about. So read this. Okay, it is diluted for normal people क्योंकि ये medium पे रखा हुआ है. So that will give you a lot of story-wise knowledge about how particles evolved over these years. And as I said, it is called particle zoo. So one of the incidents is that जब पहला ये जो Nobel Prize, so everybody started getting Nobel Prize, and then you started getting big facilities and all that thing. So हर accelerator facility में कुछ न कुछ निकलता है. They started like, okay, they are discovering Nobel Prizes. Okay, at some point the Nobel Committee said कि अब आपने कुछ discover किया ना, $10,000 का फाइन होगा. Okay, because this is called particle zoo. If you see Wikipedia में particle physics डालोगे, you will get list of all the particles. Because they also have the excited states and all that thing. So now you have pi meson, and then there's some excited state of pi meson, and then कुछ excited state. So you have so many particles to be studied, and they now behave differently. So this is what happened historically at some point. Anyways, and so how do you do the unknown है, वो experiment ऐसे मिलते हैं, and then you make the discoveries. Okay, you see what I did there. और होता है ना एग्जाम कॉलेज में कि भाई सर बोर्ड पे तो सिंपल वाला एग्जाम्पल दिखाते हैं, फिर एग्जाम में आता है तो ये होता है. ओके, सो इट इज दैट सिमिलर सिचुएशन. सो दिस इज व्हाट दैट थिंग वाज व्हिच यू कैन प्रिंट इवन ऑन अ मग. बट ये अभी तक नीचे जा रहा है. ओके, आई कुडंट पुट इट इन द स्क्रीन. So that is the Lagrangian, and that is what your entire universe is made up of. That is why it is this complicated. Okay, you want to know each and every term of this thing. इसमें सारे whatever potentials and bosons का और यहाँ जो भी है सब कुछ उसका है. इतना बड़ा फैसिलिटी है, पैसा दे दिया, तो डिटेक्ट कैसे करते हैं. ओके, so this is a cross section of a CMS detector. You can see how big it is. Okay, this is just a pie slice from this corner. There is a guy standing next to it for scaling. It is a bit, as you also saw real pictures. You can. Yeah, so this is how. So now what happens is, you see that ये इतना कॉम्प्लिकेटेड चीजें नहीं करते जो तुम अभी कॉलेज फिजिक्स में पढ़ते हो ना, इन्हीं इक्वेशंस को एक्सप्लॉइट करते हैं. For example, your charged particle will bend in the magnetic field, and then we detect things. So for example, you have this longest going particle is muon. Now you know that when you will study these particles, basic particle physics and nuclear physics, you will know that muons will interact weakly. तो वीक इंटरेक्शन कम होगा, इसलिए वो बहुत दूर तक जाएगा, कहीं किसी चीज से इंटरेक्ट नहीं करता उधर जाएगा. बट इफ यू हैव सपोज फॉर एग्जांपल दिस इज अ फोटॉन, इट्स अ लाइट. So light, push anything which is transparent, it will go through. If you put something opaque, it will put the energy there. या gamma है तो कहीं जाके वो deposit कर देगा. If you have and it will go straight. So if you have a magnetic field somewhere, you can see that in magnetic field it will bend if it has some kind of charge. So now from all these parameters, okay, कि आपको पता है magnetic, ये सब आपको पता है कौन सा mass है, you can calculate the momentum also because now you have bending. So we just use those properties. So that is what this slide is telling you. Okay, and then you have this. So now, yeah. So now what are the components? So किसी भी detector facility में, any detector facility around the planet has similar kind of structure. There will be some tracker. Tracker यानी क्या? Track करता है. So you need to know कुछ कहाँ कैसे गया. So you have different layers of silicon mostly. और इसके अंदर क्या होगा, हर जगह पे जहां पे सिलिकॉन को हिट करेगा, इट विल क्रिएट अ पिक्सल. यू ड्रॉ अ लाइन सो यू नो वेयर द पार्टिकल इज. देन देयर इज इलेक्ट्रोमैग्नेटिक कैलोरीमीटर, सो दैट इज फॉर इलेक्ट्रॉन्स और एनी न्यूट्रिनोस. तो वो क्या करेगा, इसके अंदर मेक सेपरेशन, बिकॉज इलेक्ट्रॉन है कि प्रोटॉन है, तो दे विल टर्न इन ऑपोजिट डायरेक्शन. And then at the back you have muon, because we know that muon have a very less interaction probability. So you need really large iron stacks to make it interact somewhere, and that is what we do. Okay, so ये muon detection ऐसे होता है. But this is more or less the way every detector facility will work. इसी भी detector का cross section देखोगे तो this kind of set of detectors will be there. Next. So now ये हो गया कैसे CERN काम करता है. Now we want to know what opportunities are for you. So these kind of things are there for you guys. ऐसी है, for example, this technical student program or something like that, only member state people can apply. So we are the member state from last 20 years now, and our students have these opportunities. उसमें ऐसा कुछ नहीं लिखा है कि भाई तुम्हारा IIT में होना है, NIT में होना है, ऐसा कुछ. If you think that you want to do it, you have to write a really nice CV, a cover letter, and then face the interview. If you get selected, they will take you. हमारे फर्स्ट बैच के स्टूडेंट्स जो थे NIT के, they went there. Okay, so it is not that difficult to, I mean it's difficult but still it's not like कि आप नहीं कर सकते. उन्होंने ऐसा कोई बार नहीं रखा है कि भाई ये ही यूनिवर्सिटी के लोगों को लेना है. Anybody can apply physics. By this time you should understand कि अगर ऐसा बड़ा फैसिलिटी बनाना है, you need more engineers. ओके, मेकेट्रॉनिक्स वाले चाहिए. तुमको इतने बड़े स्ट्रक्चर को 10,000 टन का डिटेक्टर होता है. जो CMS है अप टू 10,000 टन. फिर एटलास है मे बी इवन इन द सेम स्केल. तो टन्स में इनका वेट है. यू नीड गुड इंजीनियर्स हु कैन मेक अ स्ट्रक्चर विच सपोर्ट दोज थिंग्स. You need electronics and electrical engineers who can, help you pass those things by power. The electronics which we use have like जो उनका डिटेक्शन कैपेबिलिटी होता है in picoseconds. So the one which I worked on, वो दो सिग्नल 250 पिकोसेकंड अपार्ट होते हैं, तो अलग अलग डिटेक्ट करेगा. Material system which can support ultra high vacuum. अल्ट्रा हाई वैक्यूम बिकॉज यू हैव टू हैव 4 केल्विन का जो हीलियम का जो बात है वो उसके अंदर जाना चाहिए. एंड फॉर दैट यू नीड अल्ट्रा हाई वैक्यूम. सो नाउ यू नीड द मटीरियल, बिकॉज इफ यू नो फ्रॉम इफ यू रीड समवेयर दिस हीलियम इज सुपर फ्लूइड एट दैट टेम्परेचर. तो उतना इसका छोटा मॉलिक्यूल होता है कि वो ग्लास के अंदर से ही बाहर आ जाएगा जस्ट फ्रॉम द एटॉमिक गैप. स्मॉलर देन द गैप. जो एटम होते हैं ग्लास को सिलिकॉन बड़ा एटम है. हीलियम इज जस्ट one proton. You will get 2 postdoctoral scholarships and all that thing out there. So I think next, yeah. So that is the part which is from my side for now. We will do this part later on after the technical session is over, or at the end, just before the end. So that is all from my side without boring you too much. If you have any questions, feel free to ask. Questions? And I'm just like you, so feel free. Hire you. They have money. Only then they will hire you. In many cases, they might give traveling expense. Yes.
And tell what type of questions do they ask in the interview?
So again, it is also very different from the way interviews are done at South Asian countries level. They don't ask you to test your knowledge because तुम apply कर रहे हो, so they have two types of mindset. First is they know that you have margin to improve. तुमको सब नहीं आता है, उनको पहले से पता है, and they accept that